Welcome everybody. This session is about multidimensional versus tabular. We will compare analysis services in the traditional multidimensional flavor and in the new tabular way. That is the new type of modeling that you can use in analysis services. People that comes, there is plenty of space on the other side. So, okay. My name is Marco Russo. You can find my blog, my articles, some tool on sqlbi.com. There is the Twitter address, my email address, and you can contact me, send me any question you have also after the session. Today with me, there is Alberto Ferrari.
I'm not on the slide. I'm Alberto Ferrari, but today you can call me the demo monkey because
Yes.
I'm not.
You are not supposed to.
here.
Yeah, absolutely. You are
I
not.
can hide down.
Yes, please. But Alberto will help me showing some demo, trying to understand better what's happened and what are the differences between the two worlds. So the idea today is trying to compare the capabilities, especially in terms of data modeling, between the two different ways in which analysis services can work. And we will start making a short history, and we will spend a few minutes talking about X-Velocity, which is the new engine, the new storage engine inside analysis services that is the core of Tabular. After that, we will see some comparison between the patterns of data modeling that you can use and the common issues that you have when you create a business intelligence solution, when you create a cube in analysis services, what you can do now in Tabular. Sometimes Tabular is better, some other times is not. And we will make some consideration about the possible porting or migration of an existing solution. Does it make sense or not, and so on. But most important, at the end, we will try to see who wins between these two different engines. So before starting, I'd like to know from you how many of you used any version of analysis services before 2012. Please raise your hand. Almost everyone. So I suppose every one of you already know what is a dimensional model is, dimension, attribute, measures, MDX, more or less. You have an idea of what it is, how it works. Even if you are not an expert of MDX, you understand probably the basic concepts. So we will see some basic concepts of DEX, trying to understand the difference between those. And okay, I think we can start now.
Yeah.
And let's start with a short history about analysis services. Analysis services is a product that appeared on the market in its first version in 99, 98, 99, but has a first major version that was different than the previous release cycle in 2005. In 2005, we have seen the UDM, the Unified Dimensional Model, which was the idea of having a single metadata layer on top of any data so that any report, for any reason you had to write for your application, either a simple report with just an invoice or an expense report or a complex cube that aggregates millions or billions of rows, was possible to be obtained from the same set of metadata. So trying to unify any kind of report in this system. And, you know, probably this doesn't happen. This didn't happen in the past because at the end we used the UDM just for creating cubes, something that was possible to analyze with a pivot table or with a dedicated tool that was able to generate queries in MDX. We haven't seen UDM as a single metadata repository, as a single model for any report. And the point is that if you think about the name, D means dimensional. That means that you have to model the reality of your data in terms of dimension, attributes, measures, hierarchies, which sometimes is very good. Having hierarchies of attribute is a very good thing for a certain type of applications. But sometimes our data model cannot be really represented in a simple star schema, in a dimensional model, in a Kimball way. So Now, in 2012, we have a new name, which is BISM. And BISM means Business Intelligence Semantic Model. And if you think about this, we don't see dimensional anymore in the name. And BISM is the union of two different ways of describing reality. One is the multidimensional one, which is exactly what is UDM. So UDM is now a subset of BISM, and is a way to see the data, is a way to see the world, the reality. But now we have another one, which is Tabular. And Tabular is the way that you probably already know since your relational experience. In a relational database, the reality is a set of tables and columns and relationship. That's it. And you can express all of your entities in this way. And the star schema is a particular type of a relational model, but it's not a single one. It's not the only one. You can have more complex scenarios. And this is something that happens very often. Think about when you have many-to-many relationships. Think about when you have no relationship between tables, but in reality, some possible relationship exists because you can use the like between two columns that contain similar values. So you can express something in Tabular in a more flexible way. And now BISM is the union of the two types of models. So we can continue to use multidimensional when our data model can be represented in a dimensional way. And that's very good, especially if you have a lot of hierarchies in your data model. Hierarchies between attributes, I mean. But you can also have more freedom by using Tabular. As you say, well, we already have SQL Server. Why you should use Tabular? We can just use SQL Server. But the point is that in SQL Server, you don't have a semantic model. You just have table and columns. You don't have other metadata that assist a client tool to generate queries that allows the user to navigate the data. So the idea is having a semantic model that offers the same set of metadata to the external world. And the idea is that from the outside, I can see a model, either it is in a tabular model or a multidimensional one, or something that is the same. If I open a pivot table in Excel, I can connect to both a tabular model or a multidimensional model, and I can query these models in the same way. Excel continues to use MDX as a query language, and both models can be queried in MDX. But what is behind the scene? We have two ways of modeling data, and we have multidimensional and tabular. We have a language that is used internally to the engine to define the measures, to define the business logic, to define how to make the calculation. And in Tabular, this language is new and is called DAX. And DAX is a language that has been introduced in the market 2 years ago with Power Pivot for Excel, because Power Pivot for Excel is the same analysis services engine for Tabular integrated within Excel. It runs as a DLL, but technically you have exactly the same code of analysis services inside Excel. The model is the same. The engine is the same. The language is the same. And the idea of DAX is having something that is very similar to Excel, to the formula language that you have in Excel, of course, with some more functions, some more features that allows you to obtain more complex behavior. On the bottom, we have a new storage engine. And new storage engine in analysis services is called XVelocity. XVelocity is the new name for something that we was used to call Vertipack. So if you read in documentation, articles, white papers, the name Vertipack, now it is called XVelocity in-memory analytical engine, something like that. So this marketing name is good, it is nice, but in reality, the internal name is still Vertipack. And if you see, for example, the SQL Profiler event, you see Vertipack storage engine. You don't see XVelocity. But the idea is that this engine is an in-memory engine which is really fast, works in memory. It is a columnar database, and we will talk about this in a minute. This storage engine can be used in the tabular model. And today, we have a clear separation, a clear distinction between multidimensional and tabular. Multidimensional uses MDX as a formula language and uses MOLAP as a storage engine. Then you may have the option of using rollup, so generating query in SQL, so not having data stored in analysis services, but analysis services acts just as a metadata repository, as a semantic layer on top of SQL Server. And in Tabular, you have the same option with Direct Query. Direct Query is a way to use analysis services that allows you to make a query on the model, in this case in DAX, and this query is converted in SQL. So you don't have data stored inside analysis services and you have these pass-through queries that goes directly to SQL Server. We will not talk about the Direct Query and rollup in this session. We will compare MOLAP and XVelocity in particular. Now, this is the scenario. In this scenario, in an ideal world, in the future, it could happen that you can mix all the components you see in the slide in any way you want. So in an ideal world, we may be able to use XVelocity with MDX and multidimensional. In an ideal world, we may do the opposite, tabular with MOLAP, because MOLAP allows me to create aggregation. But in the real world today, if you use multidimensional, you use MOLAP. If you use tabular, you use DAX and XVelocity. The only thing that is different by now is that you can query both models in MDX. So any existing tool, any existing client tool can work with tabular like it was a cube in multidimensional. In a not so far future, it will be possible also to use DAX to query a multidimensional model. Today, you can use DAX to query just a tabular model. But in the future, this could change. This will change. Microsoft already announced that before the next release of SQL Server, there will be something that will allow you to run a DAX query on an existing multidimensional model in Analysis Services 2012. And this will allow you to use any DAX client tool with your existing cubes. This is very important if you think about the possible need for migrating a solution. Okay? Now, this is the new kid in town. We have Tabular. So Tabular is exciting, it's fast. XVelocity is really fast. XVelocity works in this way. It's a columnar database that works in memory and is a very powerful engine. And we will see some example of how powerful it is. And it is based on a way to create a data model that is similar to the way you use in a relational database. It uses DAX as a language. It no longer uses MDX. And if you compare XVelocity with the MOLAP engine, it is easier to learn. It is easier to use. DAX is much simpler than MDX. It is not so simple, but it is still simpler than MDX and is much, much faster. You may think this is not true, but we will see some demo in a few minutes. So what should we do now? Should we assume that everything has to be done in XVelocity, in Tabular, just because we have a new product now? Or should we investigate? Should we have a more heuristic approach, as saying, well, let's see what is better depending on the situation we have. And this is what we will try to do in this session. Now, analysis services can be installed in two ways. You have to make a decision when you install analysis services if you want to use tabular or multidimensional. It is a decision that you have to make when you install the product. You can install two instances of analysis services, one running multidimensional and one running tabular. It is your option. In a production environment, probably you will use just one because you will dedicate more resources just to the one that you are more interested to. But if you don't have large data models or you have a development machine, of course, you may decide to install both. The same technology of Tabular is used also for Power Pivot for SharePoint. So in reality, there is a third option that you can use when you install analysis services, that is the SharePoint. But regarding to the discussion in this session, we will compare just Tabular and Multidimensional. But remember, SharePoint is like Tabular in terms of performance and capabilities and features and so on. So what is this X velocity? I want to spend a few minutes describing what is the main characteristics of X velocity. As I said, this is an in-memory database. All data have to be stored in memory, no data on disk. Data are on disk, because when you start the server, you have to load data in memory. So when you process data, data is stored also on disk because you have sort of backup of your data. But data run always in memory. When you run a query, all the data of your database have to be stored in memory. The methodology that we use to model the database is similar to the relational one, and this is a columnar-oriented database, a columnar database, if you prefer. And is also a database that stores data in a compressed way in memory. What does it mean? Let's try to understand this, because this is very important when you think about how it is possible that big databases can be stored in a smaller amount of memory. A traditional database has a row storage layout. That means that you may have, when you think of your data, you have tables. Tables are organized in rows. And if you think about SQL Server stores this data in which way? It splits the space available in pages, and each page contains a few rows. So every time you store data of a table in your database, you store data by rows. If you have to access to a single column for 1 billion of rows, you will have to access to all the rows of the table. In terms of I/O, you will need to read all the data for all the columns. So what you do usually in SQL Server to improve performance is to duplicate data in an index. An index is a duplication of data. When you create an index, you are paying storage and I/O, because you say, yes, I'm consuming more disk, but I will spend less I/O operation to read the data that I need for a particular query. You also store data, yes, but fundamentally you are duplicating data with the indexes. In a columnar database, we have a completely different approach. Data are stored by column. What does it mean? If you think about your disk, for a moment, forget about the in-memory database. You want to store this table on disk. Each column is a file and contains data for all the rows for that particular column. Imagine you have several files, one for each column. If you want to calculate the total for the balanced view of your rows, in terms of I/O, in terms of data to read, you will read a smaller amount of data. And we already have a better I/O. Moreover, this is the way we organize data. But this has a consequence. This has a side effect. If you want to read one row, you have to materialize this row, reading data from multiple objects. You increase the number of I/O required for reading just one row, and you do this because you will improve the performance of those queries that reads many rows for just a few columns. But we are not going to duplicate data in this way. And moreover, so this is the difference between these two approaches. The materialization, creating the single row is an operation that requires CPU. We have more CPU now than I/O. And this is an operation that could make sense, especially if you consider that we are just reading data. We are not using the columnar storage database for doing OLTP, insert, delete, and so on. And moreover, we also have compression of data. If you think of the data that you have in a column, this data could have a particular sort order. And for example, we have the quarter column that contains these values. Now, when we have the same value in many contiguous rows, what we could do is try to represent the same information in a more compressed way that says, well, this value starts in this position until that position. Think to an array. Instead of duplicating this data multiple times, you just say, well, this is the value, and I repeat this value for 100 times, 300 times, and so on. This is the run length encoding compression. And we may have the same compression for many columns, and X velocity perform some compression that is similar to that. But if this compression is not convenient because we require more rows, more space, for example, imagine you have a different value for each contiguous row, then this compression is not used. You do not have to do anything. The engine automatically chooses which compression is better. Moreover, because in each column we usually have a finite number of distinct values, we also have the dictionary encoding. So if you think about our initial column quarter, we have 4 values, 4 distinct values, and a dictionary of 4 values is created somewhere in memory. It doesn't matter if these values are numbers, strings, long, short strings. Who cares? We just have 4 values. So once we have this dictionary, how many bits, not bytes, bits we need to represent a single value for each row? 2 bits. So X velocity uses the smaller number of memory required to store each row in this column. And in this way, by combining run length encoding and dictionary encoding, we may obtain a more compressed and more efficient way to represent data in memory. So this is what happened in X velocity. X velocity is much more sophisticated than that, but this is just to illustrate 2 fundamental concepts that you have in Tabular, in Vertipack, in X velocity, that you don't have usually in a relational database that stores data by row. Of course, if you think about SQL Server, the column store index uses a similar technique that, to the one that I described. But these are just indexes, duplication of data. In Tabular, this is the only way we store data on disk and then in memory. These data are compressed. They had to be stored in memory because the algorithm that we have in Tabular scans memory in a very efficient way and obtains the result of our query by using a brute force algorithm. When you run a query, the complete column is scanned for all the data, and the return is returned. There is some optimization sometimes, but in reality, this is a brute force approach that has a consequence. You don't have aggregation anymore. You don't have indexes anymore. You just have your data in the more compressed form possible, and that's it. Disk is no longer important. That data have to be stored in memory. So if you think about the differences in analysis services, hardware is different if you had to optimize a server for multidimensional or for tabular. In tabular, the speed of the RAM is the bottleneck. The speed, the clock rate of the CPU is another possible bottleneck. So it is crucial that you choose a CPU that is very fast and RAM speed very fast. In analysis services multidimensional, because you still have I/O operation, you still have you have aggregation, you have another way to describe data, the disk is still very important. And using SSD, especially if you have distinct count measures, is still very important. There are places there if you want. So this is interesting. There are different hardware for the same product running in 2 different modes. So now, what I want to do is trying to look deeper into the difference between these models. And I would take for granted that if you have a simple schema, you have, a star schema, sales analysis, you have something that works regularly in analysis services, it will work the same in tabular. It is just simpler to do. If you have a cube that you created with the wizard in analysis services, you never introduced complex MDX script, the same model will be probably easy to create also in tabular. So why you should use one or the other? Well, tabular is simpler, but you have to be able to store data in memory. But the differences start when we start introducing some more complex feature or some particular requirement. And we are going to analyze, to compare these differences. So the first important difference is that Tabular has limitation. Tabular do not have translations and do not have the concept of set. Now, I think that in Europe, the problem of not having support for translation is very important. I have seen many companies in Europe that just because of this limitation are not able to adopt Tabular today. Maybe one day it will have support for translation, but today we do not have. So you can just support one language. So you name a column in a way, and this column will be displayed to the user in that way. You cannot translate it in a different language. You do not have the notion of MDX script, and in terms of relationships, when you define the relationship between two entities, you just define one-to-many relationship. This is Tabular. In multidimensional, we have a richer data model, a richer way to define relationships, to define MDX script that applies to many calculations. So in these terms, Tabular has limits compared to multidimensional. So it starts with an handicap. Now, let's see where Tabular is stronger. Think about distinct. How many of you implemented distinct count measures in multidimensional? Raise your hands. You are lucky guy. Everyone who didn't raise the hand is not using multidimensional really, or do not have a customer that make a hard question. The point is that distinct count in multidimensional is an expensive measure. Is a measure that requires a long job for computation. The process is very expensive. And you also, if you have to optimize a distinct count measure in a large cube, it is an expensive operation also in terms of data model design. And performance are very bad during process of the model, and are also not so good at query time. So when a customer asks us, oh, I would like to see a distinct count measure for this particular, I want to see how many distinct customers I have in this period, how many distinct products I sold in this period. We always try to, you know, do you really need this, and so on. Now, in Tabular, it's easy. It's very easy. It is just a definition of a measure that do not require any particular operation in process, because any column has a dictionary that contains the distinct values. So any column is candidate for a distinct count measure without any additional cost. And at query time, it is way, way faster than multidimensional. So this is interesting. You do not need to partition data to optimize something. You do not need a special measure group. Process is good. So Alberto, can you show me something about how distinct count performs?
I'm the demo monkey. I'm here for that.
And, well.
Here we are, and we see. That's
fine. To make this demo, we thought that we needed a large table. Yep. So we usually have, we have seen 2 billion rows demo in some
Microsoft
keynote.
goes on showing 2 billion rows fact table. It's several years that Microsoft is showing 2 billion rows on Tabular.
More than 2 billion rows. There are 2 billion rows
and 7. Yeah, because they think they are cool.
And so we thought that...
we decided we are cooler.
We are cooler is not enough. Not enough. 4 billion rows. We have 4 billion rows, double the time. So this is the size of our table, 4 billion and 50 million rows. This is a database that contains data about analysis of people watching TV. You know, soccer game, strange Big Brothers, this TV broadcast transmission in Italy. And this table contains the more granular level for each minute, for each people watching TV, a row that says who is watching what at that particular minute. Of course, there is a sample of population for that, but also for every minute, 10,000 people, 4 years, we have 4 billion rows. And there is also a many-to-many relationship with other tables. So each individual that watches TV is related to many groups, because I am a male, I am a husband, I have 2 children, and so on. So all this information makes me belonging to several groups, and there is a many-to-many relationship in the middle. And the bridge table for that is 2,000,000 and
2.5 million.
2.5 million rows.
More or less.
Something that, okay, this data model, we try to implement this data model in multidimensional. It doesn't work. Okay? So there is no way to make a good optimization for this data model to make it queryable with multidimensional. So let me show something. Let me show some distinct count measure in this 4 billion rows table, please.
Okay. So we have 4 billion rows, and the good news about Tabular is that you don't need to model distinct count. You just query for distinct count. So distinct count are just one way of querying data. This first query, you can see on top the correspondent select in SQL, if you are not very familiar with MDX. But this query basically does a group by year and month name over the 4 billion rows fact table and computes the number of rows and the distinct count of ID individual. So I do a distinct count on the surrogate key over the fact table. We can execute it, but I need to, take a look at CPU while it runs. The cache is clear. I have cleared a few seconds ago, so it's already computing. And you can see on the left or right, depending on the way you're looking at.
Don't care. Don't talk too
all
much.
cores are 100%. And in order to compute distinct count, it took 6 seconds over 4 billion rows. I guess if you are able to get the same performance in multidimensional, then
and you obtained
I want to hire you.
You obtained how many rows? Because we have, for each row, we have a different distinct count, right?
Yep, I have no idea. I don't have a count, but
a few rows. Okay. Now, you are counting what? You are counting the number of individuals, right? ID individual.
Well, not really. ID individual is the surrogate key, and we have a slowly changing dimension too.
You are lying. This is not the right measure, because this is the number of versions of individuals.
Yep.
I want to know how many different people, even if a people changed its version in slowly changing type 2 dimension, I want to make the right count. I need the application key, not the surrogate key. So please fix this query.
Okay. Luckily, I have already done it. Another good news about Vertipack is that since you don't need to model distinct count, but you just query for them, by slightly changing the query, you will be able to do a distinct count on any attribute. What I'm doing here is changing the way I do the distinct count. So in the same query, I do a distinct count on ID individual, and then a distinct count on the code of the individual. One is the surrogate key, the other one is the natural key.
And to do that, you needed to join the fact table is joined to the dimension individuals, right?
Yeah,
so this is a star schema.
This is a classical star schema.
But we have 3 inner join. If you look at the SQL code, we have 3 tables joined together. Audience, data, and individuals. Okay.
Okay.
Okay. Should we go... Can we get a coffee?
It was, yep.
Yeah?
No.
No? Really?
It was 6 seconds before. Now I think it's going to be slower. But again, all cores are running 100%, and it takes 9 seconds.
Oh.
So the difference between the two is not very high. And you will be able to compute the distinct count on the code of individual, on the name of the individual, on the age, on whatever you want.
You didn't clear the cache. Clear the cache before running the query. You know.
Let's clear the cache.
Okay?
I have no idea why you don't trust me after so many years.
I never trust you. I can trust anyone here, but not you.
And so we can run it again. Of course, it's going to take a bit longer now because the cache is completely clear and he has to reload some data. But again, it shouldn't take so much longer. It's taking a bit longer, 14
seconds, okay.
Anyway, the same query, if you try to run the same query on any multidimensional model, not on a laptop, but on a big server, I think you should measure the time in minutes, not in seconds.
Okay, the 4 billion rows table that Alberto is using occupies about 14 gigabytes. 14 gigabytes.
14 gigabytes.
Okay? 14 gigabytes, and the laptop has 32 gigabytes of RAM. Nice. So, move on. Interesting. What about aggregations? Aggregations are hard to design in multidimensional. it's something that requires maintenance over time, because you have to design aggregation based on the type of the queries that users make. It's similar to the way you have to maintain indexes in a relational database. Now, because in Tabular we do not have any aggregation, we always have a brute force approach. We just have the cache, which is very important. In a human cube, not 4 billion rows, the cache is fundamental to get always data in a below second range, especially when you have an increase in workload on the server. So you also reach scalability thanks to the cache. And the fact that in Tabular we do not have aggregation, I think is very important if you consider the total cost of ownership of your solution. You do not have to plan to spend time on your cube anymore, just to refresh and to consider creating new aggregation to optimize the response time according to the type of query that your user are doing on top against your cube. Another thing that is interesting in Tabular is that if you consider the leaf level calculation, having a formula in MDX, in multidimensional, that requires leaf level calculation is always a pain. You do not have, you cannot just rely on existing aggregations, and you probably have something that have to scan the data and introduces some slowness in the process. So when I have a calculation that have to be done at the leaf level, imagine, for example, currency conversion. So let's talk about simple things. You have a table that contains transactions made in any currency, and you want to obtain a report in any other currency, and you have in the middle a table that contains the currency conversion table for each date. You can do this in multidimensional. You can model this. You can use measure expressions to do that, and you can also try to optimize this. But if you have a large cube, this will be always a pain. This will be always something that will require you to choose one or two currencies and try to make the calculation up front in the ETL, store the data already calculated somewhere, and trying to optimize a few reports for the most used currency without using the currency conversion on the fly. So when we have leaf level calculation index, Alberto, what can we do? What can we obtain? What can we expect?
To be fast, of course.
Yeah? Let me show something. Show me something.
Okay. In order to take a look at how leaf level calculation happens in DAX, it's useful to run a query on a data set without using leaf level calculation. So we just compute an aggregate, and then we run the same query but performing leaf level calculation. So we see the difference between the two. This query looks very complex, but in reality it's just doing a group by over year and age range of count rows, which is always the count of the rows, and then I sum one of the measures in my fact table. So it's just the sum of one measure over the fact table, nothing really complex. If I execute this, I always forget, okay, that I need to show the task manager. You see, all cores are running up, and the query is executed more and less in 4 seconds.
Okay.
So this is our baseline. Now, on the same data set, we do a completely different query. Maybe I can zoom it. Whoa, it works. SumX iterates over the table. So before I have simply done a sum. Now SumX iterates over audience and performs a multiplication of weight multiplied by age, and then divides everything by the sum of age. It's doing a weighted average of the age. Okay? This is a computation that goes leaf level. So for each single row of the fact table, it's going to compute this number.
At query time.
At query time, of course.
No aggregation.
You cannot aggregate such a measure, of course, because being a leaf level calculation, there is no way to aggregate it.
Okay.
And if I run, it was 4 seconds. Now I haven't cleared the cache, but the leaf level calculation, of course, is not cached because it's a completely new calculation, and it takes 3 seconds. If you clear the cache, you are going to take 4 seconds.
It seems.
So basically, the difference is that
It seems faster.
it seems because of the cache.
Yeah.
If you clear the cache, you will get exactly the same result. Basically, if you go leaf level in DAX, and if you do it in the right way by pushing the formula to the storage engine, you see really no difference between going leaf level or at the aggregate level. Basically because you don't have aggregates. The speed you see is always leaf level computation by the vertipaq engine.
I think
which is, again, pretty cool, I think.
This is interesting because I think that it has some side effects on the way we can create the data model. Because we don't have to store the data already calculated in the data model, in the SAS schema, and we can keep the original measures, and we also probably obtain a lower number of distinct values and a more optimized data model. Something that can be discussed.
Yes, that's the life of GIF. You always have to learn new ways of doing things.
Okay, nice. Okay, so there is another consideration that can be done. When you start thinking about Tabular and you realize how it works, there is something that we usually do that probably is no longer required. And this is something that I think will require a lot of time to many people to be understood and to be, because you had to change some habits. I try to show you an example in terms of data modeling. There are many, many patterns in dimensional model. Which solution is creating a snapshot, creating a table that contains data that represent a snapshot in time of an event. For example, think about the warehouse. You want to know the stock availability of any product over time, to look at a chart that says how much stock of a product you had over time. What you usually do is creating a table that contains for every month or for every day the value, the availability of each product that day. And if this product haven't made any movement over 1 month, for 30 days you will have the same row with the same value repeated several times. Because this is faster to query when you want to create a chart. This is the same that you do. Any bank represented the amount of money in its accounts and in accounts of their customers with a snapshot every day or every month, just to see this trend over time. Portfolio, insurance policy. What was the risk 1 year ago, 6 months ago? There are a lot of industries that are so used to obtain the result of a problem by doing what? Duplicating data and performing some calculation in the ETL or before the query made by the user. But now I still a slogan, think different. I mean,
it's not the right slogan here.
I know, but this time we can use it. What is a snapshot table? It's a duplication of data. You have transactions that defines what happened, the movement, the subscription of an insurance policy, the contract for a management, an investment. Every single transaction is an OLTP line, is an OLTP transaction in the OLTP database that is represented in a fact table that represents the movements. But in reality, we apply an aggregation that creates a snapshot that says, oh, in this state, this was the state of this contract, of this policy, of this, the availability of this product. This is what we usually do in the data mart, because we obtain a star schema that can be easily queried, and you use the last child, the last non-empty measure in multidimensional to obtain the right value, because you want to aggregate any dimension but the date. But if you think about what you really need in a normalized model to represent this information, in a normalized data warehouse, not necessarily made with the Kimball methodology, you can represent your data just in this way. Because you can obtain the snapshot in any moment by just aggregating, by just processing the fact table. Now, try to think for a moment, what will happen in multidimensional if I try to obtain the snapshot at query time in MDX. We have to run a query like this. In this query, we are going to get the quantity. We want to aggregate the quantity, grouping all the days, starting from the start of the history in our data until the last day of the period that we are considering. And of course, if you are displaying a chart with the trend in the last 12 months, you have every time, the first month is just 30 days, but the second month is 60 days, and every month has to compute again data of the previous month. But you can optimize this. You can create aggregations at the day level. But if you do that, every time you change the slicer, and every time you add a new filter, your aggregation is does not longer work, and so you try to create a new aggregation to cover the query made by the user. You can use this approach, but it is very hard to obtain good performance. And for performance reason, you create the snapshot. There is no need to create the snapshot for a data modeling need. The data model is this one. We have the data here. We can obtain the snapshot from this data. But for performance reason, we created the snapshot. Now in DAX, this is the same query that we can create in MDX. And because DAX uses a brute force approach, it has the same performance. The same performance when you create a snapshot on the fly than if you create a query that says last date. Which is better? It is better having less data in memory because you have less data to scan. So in theory, from a theoretical perspective, the approach of creating the snapshot on the fly could be faster than creating the snapshot at query time, removing the need to make this calculation up front. So this is something that is going to change the way we think data modeling, I think. And this is important because we are so used, I am so used to create snapshot that I try to use snapshot in Tabular. And I found that sometimes this is a trouble because I don't have enough memory to store my snapshot, but I have enough memory to store all the transactions. So I can use Tabular in fields where people say, oh, we have too many data. The question is, are you sure? Are you sure that you have too many data? Why you have so many data? You don't have so many transactions. You duplicated data, and for this reason you have so many data. So this is something, we don't have a demo here because this is in reality something that we are exploring in these days. It is new for us too, but I think that it was a too important thing. We talked about this with many people at 2 weeks ago at TechEd, customers, people that explained their problem and said we cannot use Tabular because we don't have enough memory. There is no server with enough memory, and the reality is not true. It's not true. So this is something that is interesting. Other scenario, many-to-many relationships. Well, multidimensional has a way to create a model with many-to-many relationships. And once you do that, you can query the model and obtain right result. And it is not so bad. I mean, with a small cube, it is fast. With a large cube, it is hard to optimize, but sometimes it can be used. Sometimes it cannot. The problem is that with many-to-many relationships, we have a bad usage of aggregations. It is hard to optimize because it is hard to obtain a good aggregation schema. And now in Tabular, it is not available.
We don't have many-to-many in Tabular.
We do not have many-to-many. So we would say, oh, well, we cannot use it. But the reality is that we have DAX. And we have an engine that is very fast. So let's try to write a formula that can obtain the result of a many-to-many relationship with a 4 billion rows fact table.
Okay, so again, in order to take a look at the demo on many-to-many, let's take a look at numbers of the complete data model. We still have our 4 billion rows on the fact table. Then we have a bridge table, which is 2.7 million rows. And the dimension, which is linked to the fact table, which is the individual, is 152,000 rows. So it's not incredibly big, but it's something enough to create more than one problem to multidimensional. Multidimensional is really hard in trying to answer queries over this data model. Now, on this, inside this query, I'm not going to explain all the DAX that lies inside this query, but basically by using calculate table and using the bridge table here, I'm filtering target, date, and month, and I'm computing values against the bridge table. So I'm filtering the table which is far from the fact table, and then I'm pushing the filter using many-to-many relationship.
And you also have a leaf level calculation in the query.
Yeah, of course. We already know that leaf level calculation is fast as classical calculation.
Yeah,
so
but we are mixing things together. Interesting.
And if you run this query, again, we are taking 1 month out of our 4 billion row fact table. It's all the CPU. I always forget to show the cores. All the cores are running 100%, and you get the answer in more or less 9 seconds.
Nice.
Again, you need to compare the difference between using many-to-many and not using many-to-many. Before, we have not used the many-to-many relationship, and we got the answer in 6, 7 seconds. Now, by using the many-to-many, we are increasing the speed, and we are going to 9 seconds. So there is a difference, but it's not so big.
What happens if you introduce a distinct count in this query? Because maybe people want to see, oh, how many distinct customers watch TV at that particular time.
Yeah, that's the reason why I hate customers. They always want to have everything.
Yeah. Okay.
But of course, you can create a query. I have done it, luckily.
Good.
That mixes everything. Now I do a sum x, so I do leaf level calculation, aggregate calculation by using count rows, and then distinct count over the business key of the dimension. So I think this is a really complex query, something which is pretty complex and hard to compute. But if we run it, it's not going to take, of course, much more. Now it's using the cache, if you really want to see, because I know that you are going to ask me, oh, but you didn't clear the cache.
It was just 3 seconds.
Yeah.
But
that was very cool.
Because in real world, you have
say,
several customers making similar queries at the same time. So usually the cache is used.
If this was a commercial demo, or marketing demo, then just don't clear the cache, and you see that it's faster to make more complex things. But we are technicians. So if we run with the cache completely clear, again, the reason why I want you to always take a look at the CPU is that it's very nice to have an engine that always uses 100% of your cores. That means you have spent your money in the good way. If you buy faster cores, you will run faster. If you buy faster RAM, you will run faster. So the engine is really using the hardware it uses. So it's 11 seconds now.
11 seconds.
So sorry, that's not what I wanted to do.
Very good. So we have seen until now that Tabular is very good, very fine. But now we have to look at Tabular in other scenario because, okay, that's fine. We have seen that distinct count, many-to-many, leaf level calculation, avoiding snapshot are all scenarios in which Tabular is better than multidimensional. Now let me see something about solving some common problem we already solved in multidimensional. For example, the tool dimension approach, the tool dimension pattern is something that you do in multidimensional when you want to apply a transformation on the existing measure. For example, year to date. For example, show me the year to date. Show me how you make a how you make a transformation on a particular calculation for an existing measure in Tabular.
I'm going to show you using Power Pivot. Power Pivot is the same engine, so we don't need to use Tabular to do the demo.
It is easier to see because it is more direct looking at the result.
And the user interface is better, but we cannot say that. Anyway, I have created a cube that contains a sum of sales amount year to date, sales amount running total. So I have a lot of different time intelligence functions that are applied to sales amount. And the customer says, okay, but I don't want to have all these measures. I want to have only one measure and then one dimension that let me choose the calculation that happens. So
there is a wizard that will do that in multidimensional.
There is a wizard in multidimensional? Yes, there is a wizard too in...
Yeah?
Yeah.
Really?
On Excel. Yes, it's
I
my
have-
blog. You go there, you
Ah,
read,
your
follow the
blog.
steps, and it's very easy.
Okay.
At the end, I have created a sales amount tool, which is a measure.
Yeah.
And by changing here, I take the parallel period or the running total or the year to date. And so by using only one measure, I can hide everything. And my customer is very happy because now he has only one measure that computes everything and life is easier.
So you can move the date calc on the columns, for example, instead from the slicer.
Absolutely.
And you can obtain the same result. And of course, in this case...
we need to remove the filter, of course.
Okay.
And now you see all the values divided by the dimension, which is very
show
cool.
me the code. I want to understand how much time it's required to obtain this result. And
That's
how...
not very complex, of course. If we take a look at the measure,
increase the font.
you can see that it's very simple. If has one value is just dependent, then you do a switch. If it is parallel period, the code for parallel period. If it is running total, the code for running total.
But you just created is like a case that redirected the calculation to another existing measure. So if I want to apply this year to date to 30 measures, what I had to do?
Copy and paste.
So you have to create every year to date calculation for every measure, every...
That's life.
Okay.
I think this is one of the points where DAX is not so good.
In MDX is better. Just a few lines of MDX script and I solve the problem. Okay, let's move on another thing. Parent-child hierarchies. I know that in multidimensional, there are data models in which I have a single table with a parent-child relationship and the hierarchy is automatically generated by reading data. I think that it would be nice having this support in Tabular. So in Tabular, unfortunately, it is not supported. I mean, it is supported in a way that you have to naturalize the hierarchy. You have to transform your single table that has just the code and the parent code and a description of a hierarchy into a table that contains one column for each level of the hierarchy. This is what we call naturalization. There is a wonderful tool for Visual Studio that is called the BISM helper that with a single click generates everything for you in multidimensional. And we do that in multidimensional for performance reasons, because parent-child hierarchy are not always very fast. But for not so big models, they are good. But Tabular requires you to naturalize a hierarchy and do not support the hide member if property. So let's see. Show me the parent-child hierarchy in Tabular.
That's fine. It's very easy indeed. I have a hierarchy like the one you see here. I have node ID, then the node and parent node ID. So it's a standard parent-child hierarchy as you normally build in any data model. Then by using calculated column, you create a hierarchy path and then several level columns that you aggregate inside the hierarchy in order to show the final result. That's nothing complex. You can just follow instructions from any blog post that speak about it. And once you have the hierarchy, you simply put the hierarchy there.
Yeah.
And from the invoices, which is our fact table, I put the amount, and that's a parent-child easily working.
Drill down.
Yep.
Navigate the hierarchy. Annabelle has...
One level is enough?
No. I want to see more level, and show me everything.
I wonder why. Expand collapse up to level 3, and expand all the levels will be visible.
Well. Annabelle is my CEO. Why I see Annabelle at every level of my hierarchy?
Because the hierarchy is not ragged. The hierarchy is ragged, but Tabular is not able to show ragged and to handle correctly.
You should hide Annabelle that is duplicated in the lower levels, right?
That's parent-child out of the box.
Oh, my customer
That's
is not
very
happy.
sexy,
My customer called me yesterday that said he don't like it. So please fix it.
Luckily, I have already done it. So by using a very simple measure, you remove amount, you need to write some DAX and put sum of amount, and this is the way parent-child should look. Okay. Now you see that Annabelle is just a top-level node, and you have a correct rugged hierarchy which is working. So it's just a few lines of DAX.
Show me the code again.
Well, basically what you need to do is to create one measure, which is not very easy. You need to compute the browse depth inside the DAX in order to do that. And then if you are browsing below the current level of the hierarchy, you blank the row.
So anyway, we have a workaround for this, but it is not really so easy like it is in multidimensional. So there is a support, but in reality, multidimensional is way better if you have to handle this in a regular way.
And moreover, the problem is that if you have many measures, of course, you need to replicate the code for all of the measures.
Okay, so when I have a parent-child hierarchies, one or more parent-child hierarchies, I may also have unary operators. This is especially true in some financial application. You have the balance account, and at a certain node you want to subtract all the three below that level. Can we do that in Tabular?
Obviously.
Really? I haven't seen of how to do that in the user interface in Visual Studio. How you do that?
You simply write some DAX code. It's not hard.
Since
I know that you are going to show me, I want to see the rugged hierarchy. I have already prepared this wonderful report that shows the hierarchy and the amount that contains a unary operator. You see that we have numbers that sum or numbers that are.
But originally, the numbers in the fact table are all positive. But
in the original data, all the amounts are positive numbers, and then by using a unary operator, which is the operator used to aggregate the child over the parent, you get the final result.
It works, right?
Yep, it works very well.
But show me the code again, please. Just take a look.
Again, the code.
Yeah.
Why do you want to look at the code? No customer will ever want to look at the code.
Yeah, but we had to design the solution for the customer, so we had to know how pained it is.
You know, it's pretty easy. You have to naturalize the parent-child hierarchy, then you start with the unary operator, you convert it to a multiplier. Then you have to make a few columns which are designed to use at each level of the hierarchy, and at the end, once you have created a few columns, the final piece of code is, I cannot say it's very elegant, but it works, and sometimes it is enough.
Yeah?
You see that.
You load the switch statement in DAX, I see, because every time you switch.
Depending on the level, you use the correct sign for that level for the fact table measures, and you sum them and you compute them.
It seems the Visual Basic approach in analysis services, but anyway.
Don't say that word.
Okay. Okay,
you already said Visual Basic and think different at the Microsoft side. It's not very
Visual Basic is a product from Microsoft. I mean, it is not supported
anymore. Is it a product?
Yeah.
Okay.
Well, we have seen unary operator, and another feature we have in parent-child hierarchies are custom rollup. Custom rollup are formulas, MDX formulas at each node that can apply different calculation. Do we have something to do that?
No.
Absolutely not.
You have no way to do custom rollups in DAX.
When you have a complex calculation business layer in a cube, you do not have a real alternative in Tabular with DAX. So this is the point. What about MDX script? Many scenarios that we have seen now are usually solved by using MDX. And the MDX code is hard to write, but is generic enough that can apply transformation to other areas, to other measures, to other dimensions in your cube. You do not have anything similar to MDX in DAX. And this is the reason why we see this code duplicated, this if switch, and all these things. So DAX is easier, but has no sophisticated concepts like the ones that you have in MDX. So the idea is that if you want to use Tabular for these things, you have to transform the custom rollup in something that you produce at the ETL level. Hierarchies. We can create hierarchies in Tabular. We can create a predefined path for the user. So you drill down on year, you see the quarter, the month. You drill down on the country, you see the state, the city. But in reality, these hierarchies are just user hierarchies. We do not have the support for the hierarchies in the calculation engine. That means that when you want to make a simple ratio to parent calculation, you don't have a way to write this expression in DAX without having a detailed knowledge about the data model. This is completely different. In MDX, you say ratio against the parent. You don't know which is the level, the parent level. It just works. In DEX, you have to know what is the level above, because you have to move the knowledge about the data model inside the formula. And this is a different approach. It could be better, it could be not better, but usually it is more automated in MDX than in DEX. So the idea is that should I migrate my solution? If you have a cube in multidimensional, do you have the need to think, oh, I have to move to Tabular because this is the new product, I have to be on top of the technology? Well, really, it is not necessary. If you have a working solution in multidimensional, you already have something that works and probably works better than in Tabular. You have a different modeling options in Tabular that can solve you a few problems that are not well solved in MDX. So the idea is that migrating is not a good idea. Also because you do not have a way to migrate the solution. You have to create a new project, and it does not make sense, in my opinion, to create a tool that I migrate a multidimensional model into a tabular one. It does not make sense because there are so many differences that in order to optimize the data model, it requires you to design the data model a little bit different in Tabular. Think about, for example, the problem of the quantity, price, and sales amount. So it is better to store data in a more normalized way in Tabular because you compress data better. And so it does not make sense to migrate an existing solution just because you want to migrate, unless you have a specific problem. You have in a cube, you have 5, 6 cubes in your solution. One of these cubes is slow because it has many distinct count measures and many-to-many relationships. You may think to migrate just that cube, creating a new model for these reports without touching the existing ones. This is one idea. So who is the winner? Tabular, multidimensional. Well, the answer is, the magic answer made by a consultant like me to any question. The first answer is, great, I love you. It depends, and this time is true, because it depends on many aspects. Tabular is not the new UDM. Tabular is one option you have for designing a semantic model. It can run side by side with multidimensional, using the same server or not, depend on the performance, on the size of the database, something like that. DAX is easier to learn and use, and you have different modeling techniques. So the idea is that you should consider this as an option, not as a thing that you have to do for a particular way, for a particular reason. So, what are the suggestions? Should I migrate from multidimensional to tabular? No. I have a simple answer in this case, unless you have a specific problem. I already have multidimensional cube. I know MDX. What I have to do tomorrow for a new project? Well, continue to use multidimensional by default. You already have the skill to obtain a solution in a fast way. You already spent the time, a lot of time, learning MDX, multidimensional. You have a very rich tool. You can use it. Consider tabular. If you are in this area, you already know multidimensional. Many of you know multidimensional. Consider tabular for specific issues, not for the solution to anything. But if you are new to analysis services, if you have people in your company that are new to analysis services, you may consider starting a new project in Tabular. Why? Easier to learn. So you can obtain the same result faster. That's the point. But check requirements first. Because with some requirement, multidimensional is better. With other requirements, Tabular is better. What should I choose based on requirement? Well, if you have the need to support translations, multidimensional is the only option you have today. if you have a calculation in the model that strongly depend on hierarchies, I know many financial applications in this area, choose multidimensional. You don't have something similar to the flexibility that MDX offer in MDX script to handle calculation over hierarchies. Absolutely. Multidimensional is stronger here. But consider tabular. When you have many distinct count measures in the same model and many queries uses distinct count measures. Consider tabular when you have many-to-many calculation in your data model and you have large bridge tables. We didn't spend time enough talking about the size of the bridge table that Alberto used. The problem in multidimensional for a 4 billion rows table is not the 4 billion rows table. It's the bridge table that is 2.5 million rows large. If we had a bridge table of 1,000 rows in multidimensional, we may have created a good cube with a 4 billion rows fact table, but not with 2 million and more rows in the bridge table, simply because the aggregation are too many. Consider tabular if you have a dimension that you want to partition. Partitioning is something that you can do only on measure groups in multidimensional, and you cannot do in dimensions. And sometimes, some companies have 100 million rows in one dimension and want to try to reduce the time to process this dimension by processing just a few rows, the changing rows or the new rows. Now, in tabular, you just have tables. Any factored table, any dimension table in tabular is just one table, and it can be partitioned. So you can partition dimensions in tabular, yes. But note, you have to buy enough RAM. This is the only real limit in tabular that you have now. So what you have to do, if you want to use tabular, learn DAX. The reason is that DAX is the only thing that you can do to implement features in tabular. If you don't have a feature, you have to write a DAX formula. And it's the only leverage you have to obtain better performance. When you have a performance issue, oftentimes the solution is writing DAX better. Sometimes the solution is changing the data model. But my experience is that you obtain more results by changing DAX than by changing the data model. My experience in 10 years more of multidimensional, in multidimensional, oftentimes there are people trying to optimize MDX, but usually the solution is changing the data model. I try always to reduce the MDX code in a cube, not try to optimize the MDX. It does not pay well. Learn different modeling techniques. The snapshot consideration is very important. Is something that should open your mind to, think different, as I say. Spend time trying to create some prototypes. You have to get acquainted with this new kid. So don't make a porting of an existing solution. You will obtain something that is worse than a well-designed cube. If you have a new project, if you want to analyze some data that you never analyzed in your company, try to create a prototype maybe with Power Pivot and then move to tabular. Learn to think in DAX. So this is the idea of what you should do to start working in tabular. There are other sessions. At the conference, there is a hands-on lab. There is a session tomorrow with Alberto. Just many-to-many relationships in more than 1 hour. So if you want to explore all the possibilities with the many-to-many, tomorrow is you have a good chance to see more complex data models solved in tabular. Track resources, of course, hands-on lab. There are evaluation copies of SQL 2012 available. And, of course, complete your evaluation. Please evaluate the session, give us feedback, because it's important to understand if we did a good job or not. Thank you very much. If you have a question, I'm available.
Thank you.
Thank you.